In this video, we're going to go over possible answers to the most recent quiz. For that quiz, you wrote two functions. The first one, how, calculates b to the p power. The second one, vowel, counts the number of vowels in a string, not including y, by looking at one letter at a time. In this video, we're going to look at how we decided to write these functions. However, there are many different possible solutions, so you should just use ours as a guideline for what you could do. Let's look at power first. To demonstrate what we want to be doing in our function, let's calculate two examples of power by hand. 2 to the third and 2 to the negative third, because we're going to need to treat positive and negative exponents differently. Before we start, we should know what our base case is, because you should always figure out your base case when you're doing recursion. In this case, any base to the 0th power will be equal to 1. So we want to try to change our problem size by changing the exponent until we reach p is equal to 0. Let's start with 2 to the third. 2 to the third is also equal to 2 times 2 times 2. However, if we look at this, we can see that 2 times 2 is actually just equal to 2 to the second. This is how we will recurse on our power, by decreasing the exponent by 1 and factoring out one of our base. So 2 to the third is equal to 2 times 2 to the second is equal to 2 times 2 times 2 to the first is equal to 2 times 2 times 2 times 2 to the 0. And here, when we hit 2 to the 0, we know that we've hit our base case, because our base case is when power is 0. So we know that 2 to the third must be 8. We can do a really similar thing for 2 to the negative third. However, when you raise a base to a negative number, you do 1 over that number. So, like, 2 to the negative first is equal to 1/2. So, if we increase our exponent by 1 in this case, we take out a factor of 1/2. So, calculating out 2 to the negative third recursively, we get 1/2 times 2 to the negative second, increase our power by 1, which is equal to 1/2 times 1/2 times 2 to the negative first, which is equal to 1/2 times 1/2 times 1/2 times 2 to the 0. We've hit our base case, so we know that 2 to the negative third is equal to 1/8. Now that we have an idea of what our base case and recursive step will be, let's write this out in Python code. We'll use our 3-step method for recursion. First, we identify the base case. We know that anything to the 0th power is 1, so if p equals 0, we should return 1. Next, we want to look at our recursive step. We want to split our problem into smaller problems so that we are moving towards our base case. So, this actually splits into 2 different options for recursive steps. If the power is positive, we want to multiply b by power of b and p minus 1, since b times b to the p minus 1 is equal to b to the p. If the power is negative, we multiply 1 over b by power of b and p plus 1, since increasing the exponent by 1 for a negative p is the same as bringing out a factor of 1 over b. Now that we've written our code, let's check that it works. We're going to look at the cases of 2 to the third and 2 to the negative third, since we already know what the answer should be. 8, as expected for 2 to the third, and 0.125, which is the same as 1/8 for 2 to the negative third. So, our program looks like it works. For our other example, we want to look at vowels. Before start, we're going to define a variable that will be a list of characters that are the vowels that we can look for, just to make our recursive step a little bit easier. Note that Y is not a vowel here. Okay, now we can use our three-step method for recursion. Our base case is if our string is empty. Then, we know that there are 0 vowels because there are 0 letters. So, we can return 0. Our recursive step is to determine if the first letter is a vowel, and then recurse on the rest of the list. Because the first letter may or may not be a vowel, this requires 2 different options for recursive steps, depending on whether we are adding a vowel to our vowel count or not. If the first letter is a vowel, so if the first letter is in the list of vowels we defined, then we want to return 1 plus vowels of the rest of S. So S from 1 to -1, which is the last letter in our list. Otherwise, if the first letter is not a vowel, we just want to recurse on the list. So, return vowels of S from 1 to -1 again. Now that we've translated this function into Python, let's check that it works. Let's check the string hey, which should have 1 vowel. Hey, it has 1 vowel. And let's check a string with no vowels. 0 vowels, as expected. Recursion can be applied to many different kinds of problems beyond calculating powers or counting vowels. You can have recursion with a base case and a recursive step, or, as seen in these 2 functions, with a couple different possible recursive steps. The trick to writing something recursively is really just to keep calm, identify your base case and your recursive step or steps, and then, based on these, write the function in Python.